There are several easy and interesting ways to move around trace files in WireShark. The easiest way, of course, is to use your scroll bar and just move through the trace that way. But when you work with larger traces, that can be a hassle. So we can use this Go To packet button right up here, and you can click the packet that you want to go to. So maybe you want to go to packet number 43. Click Jump To or press Return, and that'll take you directly to that packet. Keep in mind that as you navigate through trace files, if you find interesting packets, right mouse click on the packets and mark them. That can help you later on with navigation. And we'll cover more on marked packets later in this section of the course. Now we also have the ability of going to the first packet in the whole entire trace and the last packet in the trace just by clicking these buttons. I'll go to the first packet in the trace, and we can see by looking at that middle window, the middle pane, that I'm on frame number 1 now. And I can go to the last packet in the trace by clicking the down arrow, taking me to the last packet in the trace. Now, if someone tells me something's interesting, so there's something interesting, let's say, in packet number 3, I'll go over to packet number 3 by just jumping to it. And again, because it's an interesting packet, I'm going to right mouse click and I'm going to mark that packet. Now, we can use those marked packets to navigate. If we select Edit and Find Next Mark or press Shift Control N, that will take us to the next marked packet in a trace. Now I'm back down at marked packet number 43. In addition, we can go backwards through marked packets by pressing Shift Control B or selecting Edit, Find Previous Mark. And that takes me now up to packet number 3. Those marked packets will always show up with a black background and a white foreground. Now we can also use time reference to mark packets in a trace, but we're marking them using time. So let's say I go down to packet number 16, let's say, where we see an IRC response packet. I can right mouse click on that packet and set the time reference. Now we'll cover time reference in detail in section number 5 of this course. But in here I'm just setting a time reference, and all time for the packets after the time reference will be based on when that time referenced packet arrived in the trace. Now if I have another location in the trace where I set another time reference, let's say packet number 37, I'll set a time reference on packet number 37. I can go back to the beginning of the whole entire trace and I can navigate using those time references. Just as we did with finding the next marked packet, we can select Edit and Find Next Reference. That means time reference. Edit, Find Next Reference. Now I'm at packet number 37, which is the second time reference I set. Just as we did with marked packets, we can go back through our time references by saying Find Previous Reference. Edit, Find Previous Reference. And we're up at the top of the trace file now. The final thing I want to show you on navigation is the ability to use the packet history. Now, as I've been moving around in WireShark, WireShark's been keeping track of the packets that I've been looking at. And this left mouse, or the left arrow button, allows me to go back through that packet history to my previous points. So I'll click that button. That takes me to time reference number 16. Then I guess I was at time reference number 37. Remember, it's a blue highlight on my screen showing what packet I'm on. And I'll click left. I was at packet 16 before that. Before that I was at packet number 1. Before that I was at packet number 37, etc. We also have the ability of going forward in the packet history. You won't have the option of going forward until you go back, though. So it'll be grayed out until you do click the back button a little bit to go back in packet history. Then you can move forward in packet history. So using packet history, using marked packets, and using time references are some really nice ways of moving around a trace file. In addition, don't forget that we can always go to a specific packet just by entering the packet number and clicking the Jump To button. In WireShark, we can use the Find feature to locate packets based on a display filter, or based on payload somewhere in the packet, or based on an ASCII text value. So let's bring this up. Now I can open it by either clicking the Find a Packet button up on the toolbar, or I can select Edit, Find Packet off of the menu bar. Note that once you've found the packet, you can click Control N or Control B to find the next or find previous occurrences of packets that match your search criteria. I'll open the Find Packet window, and you can see that the last find operation I did was based on a display filter. Now, WireShark comes with a number of predefined display filters, and display filtering is covered in detail in section number 8 of this course. But if you want to look at this and play with this, you can click the Filter button, open up the list of available display filters, and simply choose one off of the list, or you can just type in a display filter if you know the syntax for what you're interested in. In this case, I'm looking for HTTP response codes equal to 200. That means packets where HTTP responses say OK. So I'll click the Find button, and there we go. Packet number 39 in my trace has an HTTP response code of 200. If I want to see the next instance of a packet which has the HTTP code 200 in it, I'll just click Control N on the keyboard. And here now I'm on packet number 58. I'll move that bottom window up so we can see the frame number that we're on. So packet number 58 is another HTTP 200. I'll click Control N. Packet number 70 is another one. Now I'll scroll back to the top of the entire trace, open up the Find window again, and this time I'll find something based on a hex value. Now the window will go in red because this is not a hex value. These are illegal characters for hex. So I have to type in a hex string, and I don't have to put in dashes and I don't have to put in colons between the bytes. I can just string it all together. So if I'm looking for the value AAAA somewhere in the trace, I'll click the Find button now. And here, this packet, packet number 222 in my trace, has the value AAAA somewhere inside of this hex portion down here. Now, most likely, you will use the find command or the find feature to locate packets based on a string. So, for example, I want to know if anyone, let's say, was downloading a JPEG file in this file transfer in the background. Well, the JPEG file would end in .jpg, so I'll just type that in. Now, on the left-hand side, you'll see, and across the bottom, you'll see we have a lot more options when we get to locating packets based on a string value. So we have the option of searching in just the packet list, which is the top panel, or the packet details, which is the middle panel, or the packet bytes, which is the last panel. In addition, we have the ability of saying whether we want to do this as a case-sensitive operation, looking for JPG in uppercase, lower, or only, or just lowercase, and we'd have to type it in exactly as we want it up above. If we don't check that, then it will look for all upper or lowercase variations. In addition, by default, I'll be looking for Unicode and non-Unicode ASCII sets. Now, ASCII non-Unicode uses 1 byte for a character to represent a single character, whereas Unicode uses 2 bytes to represent a single character. And that way we can handle more character sets, the global character sets of the world, using Unicode ASCII. I'll leave this set at ASCII, Unicode, and non-Unicode, although the options are to do just one of those and not the other. And then finally, what direction do I want to search in, up or down through the trace? And the default is to search down. So I'll click Find. Now it tells me that it found a packet, and here it is. It's this request to get an image, square-newcourse.jpg. Again, I can hit Control N to see if I can find another packet that matches that criteria. And there we've got downloads over.jpg, and Control N, there's another one, home over.jpg, another one, courses over, hot labs over, books over, etc. So I've got quite a few matches in here. If you were down at the bottom of the trace and you clicked Control N, a message will appear saying that the end of the capture has been exceeded. Search is continued from the start of the capture. I'll say OK, and it will start searching at the beginning of the capture, and it found something in packet number 9. This find command can be really useful when you're working with large trace files. So I'm going to open up a recent trace file that I have here that's pretty big, and this is a BitTorrent communication. And in here I want to find out if a cookie was sent in either direction in the communications. So one easy way to do that is to click on the Find button, say I'm looking for a string, and I'm looking for the word cookie embedded anywhere within the packets. And there we go. In packet number 4, the word cookie is somewhere inside of this trace. So I'm inside of this packet, and I'm going to scroll down, see if I can see it in here. And there we go. There's the cookie. If I want to see if that's occurred anywhere else in the trace, I can hit Control N on the keyboard. There's another one. And so somewhere inside of this packet we also have the word cookie. There it is. One way to make your navigation easier is to make sure that you have some really strong display filters so that you have the capability of using different display filters inside of your find commands. It's just an easy way to move around your trace files. Now, another way of finding packets inside of a trace file, besides using the find feature or the go to feature or going to the first packet or the last packet or even filtering, is to simply sort the columns. So let's say in this trace file I wanted to find all of the get request packets. I didn't want to build a filter on it. I just quickly wanted to find all of them and see all the different files that a client requested when they did an HTTP communication. One simple way of doing that is just by sorting the info column. So I'll click on the info column, and now all of the packets are arranged according to the data that's sitting in that info column. Now I'm going to scroll down until I get to the group of get requests, and there they are. So I can see that the client made a get HTTP 1.1, just getting the index, and these are all of the files that the client requested. In addition, I can scroll down further and I can see the HTTP 200 codes. And if there were any other codes, they would be sitting right after those 200s. So I would see any sort of error codes. And there's one of them right there. There's a 404 file not found. Now at this point I can click on that packet and I can reorder the columns again by clicking on the column that's the number column right there. Now they're all back in their original order, and I can see what happened in the traffic right before that 404 and what happened right after that 404. Another way we use this is to find large gaps in time. In order to do this, to sort the time column, we have to have the time value set up properly. So I'm going to change the time display format by selecting View, Time Display Format, and Seconds since Previous Packet. And that will change the time column to show me the time between the end of this packet, let's say 539, and the end of packet 540. Now I can sort the time column, and if we go to the top, these are all the very quick times between the end of one packet and the end of the next. And if I go to the bottom, these are the slower times. And we can see there's some slowness on the cabling system. We've got these 1.7-second delays between a packet and another packet. So that way, if there's a big delay somewhere in a communication, we can just simply sort the time column and identify it. Remember that once you do that, you can click on a packet. So I'm clicking on packet number 592. I'll sort again based on the number column heading, and then we can always use that Go feature to go to packet number 592 easily and just jump directly to it. Obviously, this is also a great way to group your protocols together. So if I click on the protocol column heading, that way I can find all the packets that meet a specific protocol type. So all my DHCP packets are now all together. My browser packets are all together. My DNS packets are all together. Of course, you learn so much by looking at DNS traffic on the wire. You find so much about where people are going and what they're doing. Now, although the expert system is covered in detail in section number 7 of this course, I'm going to show you how the expert system can also help you find a packet. Now, I'm going to order this packet according to the number column, and I'll go up under Analyze and select Expert Information. Now, I really only care about, let's say, errors, warnings, and notes. And here I see a duplicate ACK. It tells me that it's packet number 540, but the nice thing here is that I can click on that particular expert line, and it's highlighted that packet in the background. It's a quick and easy way of getting around your trace file based on the expert information. By default, WireShark will colorize the packets, and that makes it easy to differentiate between different protocol types. For example, you can see in this trace, My DHCP traffic is showing up with this light blue background. TCP traffic is showing up with this green background. But I've also got DNS traffic showing up with this light blue background. So obviously the colorization rules do not differentiate between the DHCP port numbers and the DNS port numbers. It must be based on something else. We can go through and we can edit those rules so that certain types of traffic show up with maybe light blue on a black background or things like that. And we can change the default set of colorization rules. Here we can see there's got to be some sort of a colorization rule based on this type of packet. It's an HTTP packet, but it's also a TCP reset packet. So let's go through and look at the default set of colorization rules, and then I'll show you where those are kept, and I'll show you how to add a rule. I'll show you how to export those rules and how to import rules from someone else. First of all, we'll select View, the Coloring Rules area. And here is the default set of coloring rules. I've got a brand new installation of WireShark here, and I'm just using the default set of rules. We can see that there's a set of rules at the top that have a black background and colored foregrounds to highlight them in the trace file. Typically when things have black backgrounds, we think of those as being problem packets. One thing to note when you're working with coloring rules is that this list is processed in order. In other words, if there's a packet that is an HTTP packet but it has a bad TCP flag setting, it would match this first criteria up here, the very first rule, before it would ever get down to be colored in green, saying it's an HTTP packet. So that's one of the things to watch out for. You have to be very, very careful on that, and we'll have to be careful on the rule that we build to make sure that it's processed properly. Now as we scroll through here, we can see why in the background our DNS and our DHCP traffic was colored. Here, let me go back up to the beginning of the trace. Why our DHCP and our DNS traffic was both colored with this light blue background. It's because both of the packets are matching the UDP rule. If we wanted to, we could add a separate rule for DHCP traffic and say that DHCP traffic should have a yellow background and a green foreground or something like that to differentiate just a little bit more. Now we're going to build a brand new rule here, and we use our display filter syntax in order to build these rules. Now, display filtering is covered in detail in section number 8, but I'm going to build some display filters just so we can work with the rules in here. First of all, I'll click New to build a brand new rule, and this rule by default will go at the bottom of the list, so I may have to move it to a different location. Now the first rule I'm going to make is for DHCP traffic. Now I'm going to call this rule DHCP, and now I've got to put in the filter string, and this is a display filter string. Now a lot of people will put in DHCP and wonder why we still have a red background, indicating that this is not a valid syntax. And it's because we use bootp when we're looking for DHCP traffic. Now I've got to define what the foreground color should be and what the background color should be for that traffic. So I want bootp traffic and DHCP traffic to show up, let's say with a red foreground. So I'm going to click in the red area right here. You can also click along the color wheel on the outside to move that around. So you can be very specific. You can even go down and give the HTML style hex color value if you want. So I'm going to say that it's got a red foreground. Let's put it this color. It's kind of ugly. And the background color, let's make it really ugly. We'll make it a yellow background. I'll say OK. Now it will show me what it will look like up there, which is kind of nasty, but that's okay. It'll really stand out in my trace now. I'll say OK. Now that rule has been added to the bottom of this list. I'll move the cursor away from it so you can see that it's colorizing it in the list. Now the problem I have with where that rule sits is that DHCP traffic runs on top of UDP. And if this list is processed in order, a DHCP packet, as we go through the list and we're looking through to see where it matches, it will hit the UDP rule and be colored a light blue. It will never make it down to the DHCP rule. Now, if we wanted to show up with this yellow background and this red foreground, we're going to have to move that rule up. So I've selected that rule, and I'm going to click the Up button to move that rule up above UDP. Now I want to try that out and see how it works. So I'll click Apply. I'll say OK. And there we go. Now we can see our DHCP traffic is showing up in yellow. You can make some really complex colorization rules. I'm going to add one now to highlight any HTTP 404 file not found error messages. So the first thing I'll do is go to View, Coloring Rules, make a brand new rule. I'm going to call this HTTP 404. Now the string here is HTTP response code equals 404. Now we can see in the background that it's gone to a green background, which indicates that WireShark recognizes that syntax. Because this is a type of an error message, I want that background color to be black. So I'm going to focus on a black background color. Now the foreground color, now of course right here we can make it almost invisible. The foreground color, let's see, since we already have some that are in yellow, I'm going to go to a light blue. There we go. Now that's what it should show up like when I have an HTTP 404 file not found packet somewhere in the trace. I'll say OK. Now again, it puts it at the bottom of this list. There it is. It's the very last entry. Now unfortunately, if you look at this list, a TCP packet with bad flags that is an HTTP 404 message will show up with a black background with this red foreground because it'll hit this rule first. Now I may not have a problem with that, but here we can see all HTTP traffic would hit this rule, this green background with the black foreground. So I definitely want to be above that particular rule. So on my rule down at the bottom, once I've selected it, I'll have to click up, 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 and keep moving it up until it's just above the HTTP rule. Now I'm ready to apply this and see how it works. So I'll click Apply and OK, close that window down. Now, if there are any HTTP 404 messages, they should show up with that black background and that light blue foreground. Again, we could build a filter on this to bring it out, but I just wanted to do it with colorization. And here we can see packet number 544 is an HTTP 404 file not found packet. Let me show you where the color rules are kept for WireShark. The default set of color rules or color filters are kept in the WireShark directory in a file called Color Filters. We can right mouse click and say that we want to open that file, and I'm just going to open it up with WordPad so it's nicely formatted. There we go. And there's a note in there saying don't edit this file because if you totally screw up all your color filters and your color rules and everything and you want to get back to this version, you don't want to have edited this particular copy. Now I've added a couple of rules and they're not in this list. So where are those new rules kept? Well, they're kept in your profile directory. So let's go over and see the rules that were kept in my profile directory. I'm going to close this window down, go over to my profiles directory. There's WSU Developer is what I logged in as, Application Data, WireShark. Here's where my capture filters are kept. My display filters are kept, my special host file I made, and my general preferences. And there's my color filters file. So I'm going to open that up. Again, I'm just going to open this with WordPad. It'll be nicely formatted for me. And there we go. Now there is one of my new rules sitting right here. There's my HTTP 404 rule, and there's my DHCP rule that I created. Now it still says do not edit this file, and you can change that if you want. You could say this, this is my personal rule set. But typically we don't go in and edit this rule set at this level. We go through and we do it all with WireShark. So I'm going to close that down and not keep those changes. If you build a really hot color filter set in WireShark, you can export those and share those with someone else. So bringing up the coloring rules window, I can select that I want to export those coloring rules, and the file name will be color filters. So I'm going to call it color filters, but I'm going to say from Laura. Now I can share that with someone else and they can import it into their WireShark system. And here we can go out to that directory and we can even look at that. So here I am in the directory and there's my copy. If you build a rule and later on you really don't like that rule, you want to change something about it, you can easily go in and click the edit button to change the rule. So I'm going to change this so it's file not found. Say OK. You can change the colors, you can change anything you want to on those rules. In addition, if there's a rule that you want to get rid of later, so maybe I don't want that DHCP rule after all, I can go through and I can just delete that one rule. At the end, I'll click Apply, and then that should change the colorization of my traffic in the background. So now I can see that my DHCP traffic is again with that light blue based on the UDP rule. What happens if you really totally screw up the rule set and you just hate what you did? Well, you can go through and you can revert back to the original. So I'll go to View, Coloring Rules, and you can click the Clear button. And a message will come up and say, look, do you want to really do this? This is going to remove all of your personal color settings. And I am sure, so I'll click Clear, goes through, changes again. I now no longer have my HTTP 404 rule in there. I'll apply it to the background. And now I shouldn't have that black background with the light blue foreground for that 404 message. If you don't like these colors showing up on your screen, you can easily toggle on and off the colorizing by clicking this Colorize Packet List button. So there we go. Now I'm just black and white. Sometimes that's nice, at least from a teaching standpoint, to be able to highlight a packet if my whole entire trace has got a bunch of black background packets in there. It's kind of tough to see which packet I'm highlighting. So it's very easy to go ahead and just toggle it on or off. In order to build really strong color filters and color rules, you need to understand those display filters really, really well. So I highly recommend that if you're going to use colorization, get to know how to build some really great display filters. One final note on colorization, and although we're going to cover the general statistics that WireShark can provide in section number 6, I'll show you something you can do with colorization and statistics. I'm going to select Statistics, Conversations. And here WireShark has pulled out the various conversations in this trace file. I'm interested in the TCP conversations, and I'm going to sort this according to the number of bytes that are exchanged between devices. And here I have an HTTP conversation with 11 packets and 1,198 bytes. I'm interested in what that communication might have been. So I'll right mouse click and say I want to colorize that conversation going both directions, or maybe I only want to colorize the traffic going from the A side, address A, over to address B, or maybe I want it unidirectional going the other way, or anything to or from A, or anything from A, or anything to A, and you've got the general idea there. So I want to colorize the whole entire communication, that whole conversation. So I'll click A to B and B to A, and look what it brings up. It brings up our Edit Color Filter window, and it brings up our Color Rules window in the background. Now I can give it a name. This is Fred to and from FS1, and I can select my foreground color. I'll pick a foreground color of red, and I'll pick my background color. I'll make this as ugly as I possibly can. Purple, there we go. Hard to be uglier than that. In fact, it's barely even visible. I'll have to do a little bit lighter shade of purple. There we go. There we go. Now I can say OK. Now, just as with all other colorizing rules, when we build them, they're going to go to the bottom of the whole entire stack here, and this list will be processed in order. So I really need to move that up at least to be above HTTP. Now I'm ready to say OK. There we go. I'll close this down. And now I've got that defined, and here it shows up in this really hideously ugly red on top of a light purple. We can do colorization not only with conversations but also with endpoints. When you bring up the endpoints graph, you can also select some conversations or some endpoints. So let's say we're interested in this device sending out packets using port 53. Right mouse click. Again, you can colorize that host traffic. If you do make these really hideous ones, remember that you can always go back in to your coloring rules and you can edit out or delete that specific one, or you can always say clear and go back to your original settings. There's several reasons why you might want to mark packets. One of the reasons might be for visibility. So let's say you're interested in this HTTP GET request. You can right mouse click and mark that packet. Now you'll see it has a black background with a white foreground. So as you scroll through, obviously marked packets are easier to see in the trace file. So here I've marked 3 packets. Another reason might be for navigation. So let's say you know that you've got some marked packets, some packets of interest in here, and you want to move between the different marked packets. You can select Edit, Find Next Mark, or use Shift-Control-N. And now we get down to packet number 9, which was the first packet I marked. I'll move the cursor off of that so you can see it. And then I'll do Shift-Control-N again, and I move to packet number 30, which is the next marked packet right there, and Shift-Control-N takes me to packet number 35, which was the third one that I marked. Another reason might be for saving purposes. So for example, I might find a number of packets that I want to save as a separate trace file. So there I've just marked another few packets. There we go. In this case, I can say File, Save As, and in the Save window I have several options that deal specifically with marked packets. First of all, I can say that I want to just save the marked packets that are in that trace. And you can always tell how many packets you have marked, because if you look down at the status bar, you can see that I have M:6, so I've marked 6 packets. Now it may be that you've marked those 6 packets, but some of those packets are not visible because you've put a display filter on your trace file. In that case, you could save the marked packets, but only the ones that are displayed by clicking on the Displayed button. In addition, you could say that you want to save everything from the first to the last marked packet, and that way you can get a range of packets based on your markers. I'll go ahead and cancel this out. There we go. Now another thing you can do in the edit area is that you could say that you want to unmark all packets. So now I have no marked packets, and we saw that we individually marked some packets that we wanted to save. Sometimes I'll get a trace file and I'll want to save all the packets except for a couple of the packets that are inside of that trace file. In that case, I can say that I want to mark all packets, and then I'll unmark specific ones that I don't care about. So I'll toggle that one off, I'll toggle this packet off, and maybe this packet down here I don't want to save. Okay, so now I've got 3 packets that are not marked. We can see that the total packet count is 613. Marked packet count is 610. Now if I say File, Save As, I can choose to just save the marked packets, and I got rid of those 3 packets out of the trace that I didn't want to save. That's a great way to use marked packets. I'll go ahead and unmark all of my packets. And remember, every time you open up the trace file, the marked packets will go away. This is only a temporary condition, and it's not saved with the trace file. Sometimes when you're working with WireShark, you might want to open up packets side by side. For example, here I have a DNS query and a DNS response packet. There's the DNS query for whitehouse.gov, and here's the DNS response packet. And I might want to see those side by side just to compare the request and the reply that came back. Now I could open up a second instance of WireShark and have those 2 instances side by side, or I can just use one single instance of WireShark, and when I'm highlighting a packet, I can right mouse click and say Show Packet in a new window. Now it brings up that one packet in a brand new window on top of my regular WireShark window in the background. So there's my query. Now I'll go to the second packet, right mouse click and show that in a packet window. I'm going to resize that one as well. So that way the 2 windows can be placed side by side. Now I have to toggle so that the 2 windows are in the foreground. And here we go. Now I'm able to compare them side by side. Keep in mind that when you do this, you put the packets side by side. You're not going to have some of the functionality that you have in the main WireShark window. For example, if I wanted to apply a filter based on the transaction ID, I can't right mouse click on this. Nothing happens when I do that. So you lose some of the functionality, but at least you're able to compare these 2 packets easily side by side without opening another instance of WireShark. Now it's time to test yourself in packet marking and colorization. You can print Appendix A, which will give you all of these steps for the WireShark lab exercises. In step number 1, I want you to open the trace file called bit-torrent-find-open-annidifranco.pcap. In step number 2, find the packet that contains the string MP3. Mark this packet and save it as a separate trace file called mp3-test.pcap. You may want to save this into the trace file directory that you made in the earlier lab. Colorize your DNS traffic with a white background and a red foreground. Now you should be able to look through that bit-torrent-find-open-annidifranco trace file to test to see if your colorization is correct. Now would be a good time to pause the video and complete the lab. And when you're ready to watch the answer, go ahead and restart the video. The first thing I'll do is open up the file. Here it is. And now I need to find a packet that has the string MP3 in it. So I'll click the Find button. And the last find function that I did was looking for an HTTP response code of 404. But this time I'm looking for a string. And the string should be MP3. I'm not going to say that it's case sensitive, so I'll look for upper or lower case. In this case, I'll look at the packet bytes because this is something that would be in the payload of a packet. It wouldn't be a value probably in a header structure. I'll leave it as ASCII, Unicode, and non-Unicode. And I'm at packet number 1, so I'll start by searching down. Click Find, and there it finds the packet 263. Now at this point, since I know I have to save that packet separately, I'm going to right mouse click and mark that packet. Now as you can see, it shows up with the black background and the white foreground. Now I'm going to check and see if there might be another one of those packets somewhere in here. I can do that by pressing Control-N or selecting Edit and Find Next. And that's it. It says that it's already looked through the whole trace file, and that's the only file that has the MP3 value in it. And if I look into the payload, I can see where the MP3 value is. There it is right here. That little one right there, MP3. So it's annidifranco-studying-stones.mp3 is the name of this file. Now at this point, I'm ready to save this packet in a separate trace file. Because it's marked, now I can say File, Save As, and I'm going to call this mp3-test.pcap. I'm going to make sure that I say that I want to save the marked packets. I didn't have any filter set, so it doesn't matter whether I choose captured or displayed. And I'll go ahead and save this. There we go. So now I should have that saved as a trace file. The next thing that I want to do is colorize the DNS traffic. Right now the DNS traffic shows up with this light blue background and black foreground because it's matching the UDP filter. So I'm going to go in and make a special colorization rule. And this time I'm going to make a brand new rule. I'm going to call it DNS traffic. Now the filter for this is just DNS. And again, all the display filter information is in Chapter 8 or Section 8 of this course. So the foreground color should be red. There we go. And the background color, I want the background color to be white, so it's already set as default of white right there. There we go. It's my red, and I'll say OK. Now remember, the problem here that we have with these coloring rules is that if we put them out of order, it might not work. We can see there's my DNS coloring rule that I put in there, but because DNS goes over UDP, by default when we do our DNS queries it's over UDP, those packets would hit this UDP filter first. So we need to move our new coloring rule up. So I'll click up a couple of times so it's above that, say apply. I need to verify that that colorization is correct. And there we go. Just by moving the window down, I can see in the background that it looks like it is correct. I'll go ahead and close that window out. And there we go.